Hey everyone, very good afternoon. So I'm Prakash Putta. I currently work as a staff software engineer for Instacart. And today I'm here to briefly chat about how introducing LLMs into our search stack has really supercharged in certain use cases. So before we go into the details, a little bit about me. I'm currently leading the core search in Instacart, and our team specializes in search with a focus on retrieval, ranking, and personalization. And for those of you who aren't aware of Instacart itself, Instacart is like the North American leader in online grocery, specializing in pickup and delivery. And our mission is to create a world where everyone has access to the food they love and more time to enjoy it together. And moving on to the agenda itself. So today we are briefly going to touch on the overview of Instacart search. Then we'll talk about the role of search in the grocery e-commerce space, the challenges we come across, and why we decided to use LLMs in our search stack, and some of the advantages that comes along the way. And we are going to end with some future trends and a quick summary of the talk that we do today. Yeah, as you can see here, there are majorly 4 components involved in our Instacart search stack: query understanding, retrieval, ranking, and presentation. So this is pretty typical of any modern day search stack engine, right? So query understanding has models that typically try to predict the personalized user intent of a given user query. And once you have those user signals, essentially what we try to do is we try to retrieve all the relevant products and then send it to a ranking layer. This ranking layer is usually a multi-stage ranking with different objectives in different layers. And then finally, the presentation. So depending on the context, like user, query, and platform, hey, whether it's an iOS app or a web app, we decide what the layout needs to be, and then we finally present the results to the users. So to quickly talk about this using some simple examples. So in a naive fashion, right, if you think about search is nothing but it's a traditional keyword matching. So let's say if a user searches for something like clementine, so we essentially try to find all the products that have the keyword called clementine in their product name or product description. We just find them and display it to the users. That's essentially what we're doing. But let's say if a user searches for something called cuties, and cuties as a keyword isn't present in any of the product description or product name of any of the clementines. Now, how do we recall all the clementine products for a query like cuties, right? And by the way, for the folks who are not aware, cuties is actually a brand name for clementines, which has sort of become synonymous for clementines itself. So a lot of users on Instacart, when they want to search for clementines, they just search for cuties and they expect to see clementines on the search results page. Also, a little bit of trivia, if you folks are interested. Cuties is actually a term coined in 2005, which is sort of coined because of how cute the clementines looked. So I guess this is an advantage of working at Instacart. You probably will win pretty much any product or grocery trivia out there. Yep. But going back to the original question, right? How do we recall the products for the cuties query? This is where the query understanding comes into play. Query understanding has models like query rewrites, which essentially says that, hey, the user searched for cuties, but they are intending to see products like clementines. Now, once we are equipped with this information, we change our retrieval step slightly and say that, hey, when the user searches for cuties, recall both cuties and clementines. And now we essentially have all the products of clementines as well, and we display it to the user. This shows the power of query understanding and why it's very important to have a very powerful query understanding out there. And a traditional NLP model like query rewrites obviously needs a lot of data and historical logs for it to be performant. But when you think about tail queries are essentially queries that we don't see often. They don't perform very well because there's not a lot of data about it, and those models wouldn't perform well. This is one of the advantages of LLMs, and they'll do great at things like this. And just to give a context, right? So we have around 20 million tail queries today at Instacart, and that keeps on growing from time to time. This number has been growing quite a bit since the surge of COVID, because we got more users, people are coming in, people are trying out new queries. So obviously you expect the tail queries to increase in number over time. And moving on, right, talking about the role of search in grocery e-commerce, obviously, as you all know, search is very important for any e-commerce website. But it gets even more important when we are talking about in the grocery domain. This is because when a user comes in to purchase something on a grocery website, essentially they come with a huge shopping list and they want to purchase all the items in the shopping list. So you would want to ensure that they have a smooth, personalized experience and purchase all those things very smoothly. This is as simple as like having a helper in your store when you go to the store, right? So this is how we want the search to be. And essentially, it's not only helping you find the products you are looking for, search also helps you to discover new products. This discovery of new products brings in like more exploration and obviously brings back users to the store more often. So this drives both revenue and also like retention for the platform. And CPG brands like Costco, Pepsi, right? These often use search as like a platform to introduce like the sponsored products for them to increase their brand or like to introduce new products that come in. And just to quickly talk about the scale of the data, Instacart operates at like 1,400 national, regional, and local retailer brands out of 8,000 stores across 14,000 cities in the US. We operate over a billion of products. This billion of products might not seem mammoth scale when you think about it, but when you think about the number of product categories it's spread across, that's where the problem gets very tricky and interesting. So we operate over various categories like traditional grocery, alcohol, beauty, electronics, and so on. And now that we talked about the basic architecture of search and like the scale of data that we are dealing with, let's also touch on like few of the challenges that we come across in like traditional grocery search, in our case, Instacart. So the first case here is talking about vast space of product attributes. If you look at the first example, a product can have like multiple attributes. In this case, probably cherry is an attribute, non-dairy is an attribute, almond milk is an attribute, right? There are multiple attributes. So essentially understanding product attributes for every product is very important because this is how you can personalize a search. Only by knowing the attributes can you use this information in query understanding and also in ranking to essentially boost those products. For example, if you know that, hey, user is interested in vegan products, without knowing if the product is vegan or not, you can't essentially recall the product and boost them to the top. As simple as that. So, but the problem here is that, as I was mentioning, we deal with like several thousand categories, and each of these categories can have hundreds of attributes. This is where the problem gets very tricky. Typically, the way this is done today is through an army of like domain experts who manually go through this and like extract them. But this is, as you can imagine, this is not at all scalable, and it's very costly and also error prone. And the second example here is having like different query intents in the search. So, for example, if you look at a query like breakfast, right? This breakfast can map to like hundreds or thousands of products in a store, but it's essentially not possible to recall all the products without having a deep understanding of the concept called breakfast. This is because every product wouldn't have the keyword called breakfast in it. To do this, there are a couple of ways to do this. Like one is to bring in external knowledge and like embed into our systems. This is not very easy to do because there are like multiple concepts out there. The other way is to do like build NLP models. But as you can imagine, this is like costly and also time consuming. And the third challenge here that we're talking about is the complex intents. For example, think about like a typical user that comes to Instacart for shopping. Everyone usually comes with a task in mind. It can be like a weekly grocery shopping or like maybe a party that's happening, so they need a shopping list or breakfast ideas to lose weight. Example like this, right? It'll be very useful to have users enter this complex intent within the search. Today, usually what happens is that users research about this information somewhere else and they come to the grocery website and that's where they purchase just the products. But having them enter this entire complex intent within the search is going to be very powerful. If you can solve this intent, think about the user satisfaction and also the revenue opportunities this can bring to the Instacart and the grocery itself. Moving on, before we move on to how we are trying to solve some of the problems, let's quickly talk about the advantages of LLMs that's helping like search solve some of these problems. The first one, as you all know, is rich world knowledge. LLMs can give like expert-like answers for most of the common concepts. So it can seem like, it can So when you embed this into like search, right, search can look very smart without building like very complex knowledge graphs. This is actually very good with very less investment. And obviously it has the ability to understand a context that you provide and the semantics of it. And also, the third point here is that NLPs are in general small and have like very limited knowledge. So it's very common across the academia that NLP models typically can't predict very well outside the domain. This is because of the limited training data that we provide. But LLMs solve this in a very simple and elegant way. They pretty much train on the data, text across the world, most of the text across the world. So there's no concept of out-of-domain concept here. So when you try to solve problems like tail queries for this, right? So tail query can be answered very simply, very easily here because everything is within the domain here. And the last, and I think one of the most important things, is how much faster the development cycle can be. Typically, today, if you were to build something like this, like every task needs like an NLP model. For example, spell correction or like entity linking or intent classification, right? Everything needs a model on its own. Everything needs a design of its own and data on its own, right? This is very time-consuming, very costly, and it's not like it's also error-prone in some cases. But LLMs have shown us that some of this can be easily done with like just simple prompting in a couple of minutes. That's the power of LLMs right now. And given that we quickly touched on the advantage of LLMs, let's also touch on like how we have tried solving some of the problems we talked about. So when it comes to like content understanding and like feature extraction in e-commerce domain, LLMs are actually a game changer. This is because the task of like giving LLMs a bunch of product information, product description, and asking it to extract product concepts, and attributes is actually a very easy task for LLMs. So they do a very good job. They do a much better job than like what a human can do. So as I was talking about, right, humans tend to be, when they extract it, can be error prone and everything. But this is like much faster, much easier, and much cheaper way of doing things. And also the other interesting thing, if you think about, is that a lot of times when we get information from retailers or like third-party sources, the text information that we get, like for example, product description, might not be complete all the time. A lot of times the information is just embedded into the product image here, the image that you see here, right? With the advent of models like GPT-V, what's happening here is that we can use those models to extract even more features from just from the image itself. So that's the power of product attribute extraction that LLMs is bringing on for us. And once you fetch this back into layers like query understanding and ranking, the entire search becomes very powerful. The other use case I'm going to talk about here is how effective merchandising can be done with the help of LLMs. So as I was talking about, LLMs can really understand the products very well, the product attributes very well, right? Now, let's say you take an example of summer grilling that shows up on the page here. If you were to create something like that, you would need a human to say that, hey, I want to, now this is summer, now let me create like a collection called summer grilling. Let me find an image for it, let me find some text for it, then let me go figure out the products that needs to go in and everything, right? This is a very cumbersome process. But if you give enough context to the LLM, it can pretty much generate everything. Like you can ask LLMs to generate the images, like the metadata, the context, and like the products that go in, everything, right? So now, essentially, you need not just create like one type of collection, but depending on the personalized user, right? You can create personalized collections. So merchandising gets like much more better right now. And obviously, when it gets better, like people tend to add more, and it's good for the business. And the other example we were talking about is the query tagging, right? So we were just talking about like how product tagging was, like product attribute tagging is like very helpful for improving ranking and retrieval. Let's also quickly talk about query tagging, right? So extracting attributes from a query is also like very helpful in understanding, making the search better for the user. To give an example, recently I came across this dough, wherein like I realized that, hey, there are several types of doughs that can be used for baking. So there is this dough called sugar cookie dough, which essentially, if I go and search across like a lot of grocery spaces, right, what would happen is that it will bring in a lot of irrelevant results because a traditional QU model wouldn't understand that, hey, sugar cookie is like an attribute and dough is like what the user is looking for, right? But with if you provide this information to LLM will say that, hey, sugar cookie is an attribute and dough is what the user is looking for. With this information, you can obviously pull in like a lot more like relevant results and like accordingly figure out substitutes in case you need something, things like that. So this makes the query tagging also like very powerful in addition to like the product tagging we were talking about. The other example we were talking about is like how broad intents and like complex intents are very tough to solve, right? For example, the example of breakfast. Before, it's really tough to understand unless you have like an in-depth knowledge of the concept itself. But given that LLMs have like a rich world knowledge, breakfast as a concept can be very well understood by LLMs, and they can give like a deep understanding of, hey, what do they think breakfast should mean? As you can see here, like cereal, eggs, orange juice, yogurt, or many more concepts, right? Many more sub-concepts can be given to the given back to the search, and we can make use of those things. So that's what's happening here. And the same thing is happening with something like similar to the complex intents too. I'm not going to talk in detail about that, but essentially what's happening here is that given that there are so many opportunities here, it'll open up a lot of new product ideas on like how you can use LLMs to essentially solve a lot of complex cases here. Sorry. Moving on. LLMs are not only helpful for like regular searches, but also for improving the new product discovery. So as I was talking before, right? So typically when a user comes to Instacart, they have a task in mind. Like so when the task isn't like explicitly mentioned or like even when you know explicitly, right? So you can provide suggestions to the user and guide them through the flow, saying that, hey, you bought this, maybe this is what you want to buy, something on those lines, right? Guiding the user through the flow is very, very important. Along this flow, right, what if you can also put in some inspiration to the user so that they can, so that it will encourage new product discovery. That's mind-blowing, right? Because you're not just showing what the user wants, but along with that, you're also saying, hey, these are the new products you might be interested in trying out, right? So typically, the way this is done is to like look at like the corpus of historical logs and everything, and then figure out like, hey, what queries needs to be shown. But if you look at the historical logs, right, it's just like boring queries in general. So this is where LLM gets like super helpful and super powerful, because LLM can suggest like some really interesting queries that can go with certain things. Like let's say, hey, you know, something is in your basket, probably says something, things around those lines. So the new product discovery gets like gets a step up with the help of LLMs here. And now that we have talked about how like some of the challenges we are facing and how we are approximately like solving those things, let's quickly talk about how integrating LLMs into search stack looks like. So this is a typical search plus LLM stack. So what you would have is that you would have a query, and you would have that query embedded into like the prompt, and this prompt is sent to like LLM service. And this LLM service gives out a bunch of results or answers, let's call, and these answers are then sent into the product retrieval, right? And once the product retrieval engine like fetches like products for all these answers, then we display the products on the page. This is like a typical search stack flow. This is a very simplified version of it, obviously. But even for this, right, when you think about it, depending on the use case, let's say if you're trying to get like super accurate or super precise, the LLMs can become costly in nature, because let's say, hey, you wanted to understand all the answers for a given query. Now, that might end up bringing in like a lot more answers, and for fetching products for each of those answers might be like a very expensive thing. So you should be very mindful of integrating LLMs into the search stack, and also like you should be like when you're trying to integrate LLMs into your search stack, figure out the use case and try to be like very specific to the use case. And yeah, moving on, right? Obviously, we talked about how LLMs can be very powerful in search stack, right? But what are some of the things that you really need to consider when you're integrating it? The first thing is the cost and latency. Obviously, it's going to be costly if you were to call this LLMs for everything, and the latency is a big thing because LLMs are not super fast right now. And the second thing is, what are the queries really eligible for LLMs? For example, you might not need a LLM boost for a query like milk, because we already have a pretty good understanding of it. But for a vague and complex intent, right, you might want to call LLMs and fetch that information and then use in a stack, right? So it's very important for you to understand when to use an LLM call versus like when to use your traditional search. Having that information really also is really important to productionize some of your search stack. And another really important thing is figuring out online versus offline. So when you're making an LLM call, right, for example, in our search case, when a user makes a search query, is it really essential that I need to make an LLM call in real time, or can some of this be processed offline? I think that's a really important question to ask whenever you're integrating something into production here. This is because a lot of product use cases, like, for example, the product extraction we're talking about, right? This can be done in an offline manner. And once this is extracted in an offline manner, they can be integrated back into our query understanding or ranking in an offline fashion without a hit on latency. And the cost is also more effective in that case. And even if you have to do something online, think about the ways in which you can effectively improve cost or latency. Think about caching. Think about, hey, can you parallelize some of this in with respect to like what you're already doing? Or is it possible to make some of them in async, right? All these things are really necessary to think about like when you are integrating LLMs into production. And obviously, prompt engineering becomes really important because not getting the prompt engineering right essentially means that you're not going to have like the right results that you're looking for. So ensuring that all your use cases are covered, like all the product use cases are covered, is super important when you're doing the prompt engineering. And no need to talk about the content moderation as such. This is like one of the biggest issues probably we might have to solve. So how do we ensure, or how do we guide LLMs into like not giving inappropriate results for us? For example, how do we ensure that LLMs is not giving us suggestions like, hey, how to make a bomb, or what are some unhealthy snacks? We shouldn't do anything that really hurts our business or brands or things like that. So you should ensure that some of these things are really taken into consideration when you are doing the prompt generation. And obviously, the last piece is how do you map LLMs into catalog products? When you fetch all this rich information from the LLMs, you wanted to like map them back to the catalog products, and that's really important for us. And the other hardest problem to solve here is lack of context when interpreting LLM answers. For example, let's take this example of July 4th party ideas. When given to LLM, it says that, hey, fireworks is a great query expansion. Sounds good. Now, when we recall using the traditional methods, we get an irrelevant result. So what we need to do is still embed with like traditional QU context and say that, hey, probably this is what is relevant. But this might not always be working for all the cases. Let's take the second example, right? Cheese that goes with wine. LLM says that, hey, Gouda cheese is a great example, a great cheese that goes with wine. Now, when we try to recall that, it brings in Gouda shredded cheese, but obviously we are not looking for a shredded cheese here. We are looking for a cheese block, right? Taking in this additional context and ensuring that it's recalling the right products is a very tough problem to solve. And LLMs also can easily misinterpret the query when there's lack of domain knowledge. This happens a lot with the general, not a lot, but sometimes with the general LLMs, because when you're searching for variety chips, user is looking for a product wherein there are different types of variety chips in that product. But here, LLMs is asking that, hey, user might be intending to purchase like different types of chips. And it's essentially not wrong, but some of the ways to solve this is adding via prompt tuning, or that it's not going to scale very well, because as you add like more to the prompt, it's going to be costly and the latency is going to be increasing too. And probably one of the longer term solutions here is to like fine tune your own LLM model based on the grocery database, but obviously that's going to be costly and it needs effort too and energy there too. And the last part here is probably the evaluation piece. As I was talking about, right, quickly, LLMs can sometimes misinterpret the query when there's a lack of domain knowledge. And how do we in general like evaluate? What are the criteria for evaluating if the LLM results are right? And in some cases, right, the results doesn't fit the product use cases too. For example, if the user is searching for something like granola bars for breakfast, LLM might be giving the recipes to generate that instead of like whereas the user is looking to buy something like a product that's readily available for purchase. This is not like a right answer that we're looking for, right? And also evaluation of product results becomes very important. So this can essentially be done by like online evaluation, wherein like if the new product discovery increases, it shows that, hey, LLMs are doing a great job. So LLMs are like showing new products to the user, encouraging more product discovery so that people purchase more products, right? Or an increase in search conversion rate. Search conversion rate essentially means that, hey, for a given search query, how many of the searches really converted to purchases, right? Increase in search conversion rate shows that, hey, users are really interacting well with the LLMs, and LLMs are able to understand the user's intent well. So that's why people are converting more. That essentially means that. And to end the talk, right, I quickly want to touch on the future trends. So I know most of my talk today touched on how LLMs can be used to improve the existing NLP models. But personalizing search is something that's going to be big, I feel, in LLMs. Let's say if you can pass the entire user context to the LLMs, and once you get that response, you fetch hyper-personalized results for the users. That's going to be big. And content generation, just like the merchandising example we were talking about, right? Let's say if a user searches for something like popcorn, and if you want to show a carousel of movie night essentials. Today, if you were to do something like that, you would need a lot of humans. Obviously, you need a carousel, name for it, products, and then you also need to add metadata to say that, hey, popcorn might be mapping to movie night essentials, things along these lines, right? Whereas if you can generate these things using LLM, it's very scalable, and also you can try to do personalized content generation as well. The last piece here is the search result evaluation. This is actually a very important task. When you think about it, right, the results showing that you're showing on the search page normally, for a given query, you show X number of products. How do we realize that, hey, these are relevant products or not? We go through something called human evaluation, or with the human raters really evaluating whether a given product is relevant to a given query, right? So this usually goes through a lot of guidelines, and the raters go through these guidelines and decide whether this is a valid product or not for a given query. But with the advent of LLMs, there are a lot of new models coming into. There's a very big hope for all this human annotation tasks to be moved on to the LLMs, and it's going to be super fast and super cheap too. So essentially, you might be able to use some of this even in experimentation to understand hey, if you're launching a feature, how is your search evaluation trending, things like that. And yeah, to summarize, right, LLMs are very effective in improving search relevance and unlocking new capabilities, but it's also important that we clearly understand what the product use case is, because depending on the product use case, you essentially need to trim down to how and when you want to use LLMs. And it definitely is not a trivial engineering efforts to successfully integrating LLMs into existing search stacks. And one thing is that, sorry, I couldn't get into too many technical details today because of, obviously, IP place legal constraints, but I hope some of the challenges I touched on today will spark some ideas into some of the use cases you're thinking about. That's pretty much it from me. Thank you.
Thank you, Prakash, for a very informative talk. We do have some time for a couple of questions. If you want to raise your hand, we have mic runners.
Thank you, Prakash. It was very insightful. So in terms of complex query understanding that you've shown, right? So, the complex query understanding, the prompt can be very vague, right? What user puts in there. So are you doing any prompt tuning, the intent of the complex intent of the query before passing it to LLM? You don't have to name which LLMs you're using. Are you using some of the model providers which are proprietary or open source LLMs?
We are trying a couple of different things, to be honest. So that's one of the things that we keep trying at Instacart, trying out different types of LLMs and see how they perform over time. But coming back to your question on prompt tuning, right? Definitely that's a big thing, because if you think about it, right, Instacart has a very big use case on not one prompt really works for all the types of queries that we have in place. Now, how do we essentially, we can't put all the information into one prompt itself. How do we improve on this prompts from time to time? I think is a very big question that we try to tackle from there. I don't know if I can answer more on this, but yeah, at a high level, yeah, that's the thing.
So it's a continuous evaluation.
Oh, for sure. And I think that's another thing we didn't talk on it, but even when you're doing prompt engineering, right? Whenever you change prompts, how do you ensure that the results you are getting now are different from the previous thing, and how do you ensure that the results you're getting now are the accurate ones, right? That's also very important to know, the prompt testing, and when you're talking about prompt engineering, right? When you're doing a one-off scale, it's very easy. But when you're doing it a company level scale, you need to ensure that the prompt you're putting out is not spoiling the old experience, right? Yes. So the prompt testing becomes very important. There are a lot of ways to do that, but prompt testing at a scale is very important. So,
Thank you. What order of latencies are we talking about by introducing LLMs into the search retrieval stack?
sorry, did you say what are the latencies?
Yeah, what order of latencies are we talking about by introducing LLM into the search stack?
There are two use cases, right? Online versus offline. Offline is actually pretty straightforward. I mean, not much increase in latency. Obviously, there might be some increase in latency because of recall. Like we are recalling more products. Like, hey, query expansion tells that, hey, this is like additional products you need to recall, right? So there's some amount of latency. When it comes to like online methodologies, right? So like when you introduce an LLM call, it's a typical LLM latency that you see outside. Like it's pretty big. So, but to overcome things like that, sometimes we parallelize and sometimes we also do async calls. Like already, hey, maybe something else is going on, and then now can we introduce this LLM call in parallel to that to ensure that we are not doing like a lot of this sequentially, for example. That's one of the ways we try to get around those things.
Yeah, so the ballpark is like 2-digit milliseconds or 3-digit milliseconds in general.
Yeah, you could say you are pretty accurate there. So,
Okay,
pretty
thank you.
close.
You have time for one more question?
Yeah. How are you guys evaluating ROI of these initiatives? Like, what are your main metrics and how are you collecting those?
It's a great question. I think it depends on the product use case, to be honest. So, I mean, I think that's one of the things I was trying to, stress on is that it's when you're trying to introduce LLMs, right? Don't try to just get into LLMs, but understand the product use case very well on like, hey, what you're trying to solve, right? Some of the product use cases here are like, hey, pretty much you're improving your natural language, NLP models by adding a lot of data, right? So the ROI of some of those things it becomes super easy to understand. But let's say when you're trying to introduce complex things like, hey, online calls into this thing, right? Like let's say complex intents. That's really, really tough to get it. And I think you only get some of those things really once you explore and understand like how things are done, right? Like some of them are like big bets that we take to really say that, hey, this is what we think as a thing. I mean, we don't have like a business metrics probably right going into the thing, but once we have a decent understanding, that's when we get into like really understanding how it's doing and what it's supposed to do.
Thanks.
Thank you, Prakash. Ladies and gentlemen.
Yep. If you have any more questions, I'm right here, happy to chat. As you know, I'm an engineer, so it's very easy to find me. I'll be standing somewhere in the corner, awkwardly staring at my own food. So, yeah. Cool, friends. Thank you so much.